Yeah, so in this video we're going to look at loops on a switch or a switch-built network. So in this, I've not built this network in any particular order. I've just made a nice triangle, but you've got three switches. You'll notice that some of the links are green and one of the links has an orange in, which suggests that that link is not currently working. So what's happened here is that by default, Cisco switches have enabled something called spanning tree protocol. And what spanning tree protocol does is it prevents loops from happening in a network. So in this scenario here, PC0 could go to, if it was sending a message to PC1, it could go along the bottom path, or it could go through switch 1 to switch 0 to switch 2, and that could produce a loop. So it could come back on itself and overwhelm the network with what's called a broadcast storm, because it's going to replicate over time. So what spanning tree protocol does is it elects a root bridge, and it elects that root bridge based on its bridge ID, which by default on all switches is 32768, and then it adds the MAC address. So whichever has the lowest MAC address, it will elect that naturally as the root bridge. And this also produces redundancy as well. If this good link failed, then the network learns from itself and updates it over time. So what we'll do is we'll have a look at how spanning tree works and from a configuration point of view, and we'll sort of move these terms from the left into the right place here. So first of all, we're going to have to find out which is the root bridge. So simply, like I said, by default it is enabled. So all I'm going to do is show spanning tree for VLAN 1. So we're just working on the default configurations for now. Okay, so this is showing all information to do with spanning tree protocol on VLAN 1. Now, if I wanted to enable it, I would have to go into configuration mode, so configure terminal, and then put spanning tree VLAN 1, or if it was VLAN 100, it'd be spanning tree VLAN 100. If I want to turn it off, it'd just be a simple command of no spanning tree VLAN 1. Okay, but here we can see here some information. So we've got the MAC address of the switch. It's telling us that this bridge is the root. So this is the root bridge. So switch 1 is the boss of this network. Okay. It also has some ports here with some costs. So because we're using a fast Ethernet connection, that cost has 19. So the faster the connection, the lower the cost, and it elects roles based on the lowest cost to the particular network. So I can call this the root bridge. So I'll drag this across here. That's the root bridge. Now, all these other ports here, so naturally the root bridge, the other ports away from the switch will be are called designated ports, and they're in forwarding state. So this port here and this port here are in forwarding state, and that's all we really need to know about that particular switch itself. So you'll notice here the MAC address, that will be the lowest MAC address on this particular network. So all the other switches will have a MAC address that equals a higher number than that. Okay, so let's have a look at switch 2. Let's do the same command. So enable, right, and show spanning, and press the tab key to make it quicker. Okay, so now we have a root port. So that root port is the fastest port back to the root bridge, which is going to be this one here. So that will be FAO2. Okay. And then the others are just designated ports like the other one. So here and here. So they are in forwarding state. So they are forwarding traffic. Okay. So finally, if I close that one down now and notice the MAC address here. Okay, same command again. Show spanning tree VLAN 1. Okay, so you'll notice here we have a root port. So again, that's the fastest way back to the root bridge. So that's going to be this one here. So FAO2. Okay, and then we've got the blocking port. So this is naturally the one that's furthest away from the root bridge by total path cost. So that's where this column comes in here. Okay, so that's the blocking port. Okay, so naturally now this network, a loop cannot occur. So if it tried to go down here, it'd be blocked, and the network would learn from itself and go back on itself and not take that path. And like I say, if let's say this particular port here becomes the link fails, then the network will realign itself. It sends out requests every 2 seconds for spanning tree protocol to update. Okay, so that's spanning tree protocol. There's a bit more information in the article, but hopefully that makes some sense.